4.1 Extreme values of a function. So 4.1 focuses on extreme values, and this can help in determining the shape of a water bottle to minimize manufacturing costs. It can also help determine the maximum acceleration of a space shuttle, and it can also help optimize the radius of a contracted windpipe that expels air rapidly, in this case, asthma or inhaler. Absolute extreme values of functions. Absolute maximum, the value f of c, if f of c is greater than or equal to f of x for all x in the domain f of x. Absolute minimum, the value f of c if f of c is less than or equal to f of x for all x in the domain f of x.
Alright, so let's start off with our first example here. Find the absolute extrema of f of x equals sine of x on the interval 0 to pi. Begin drawing the graph of sine. Now only look at the section of the graph between x equals 0 and x equals pi, and find the absolute extremas. There's only one absolute maximum here, and the maximum is 1 when x equals pi over 2. There are two absolute minimums here, and they are 0 when x equals 0 and x equals pi.
Local extreme values of a function. Local maximum, the value f of c if f of c is greater than or equal to f of x for all x in an open interval containing c. Local minimum, the value f of c if f of c is less than or equal to f of x for all x in an open interval containing c.
As you can see, there is a local maximum at 0 because the rest of the graph is not bounded from above, while the graph of f of x is bounded below with two minimums. And there is a local minimum in this graph of f of x at 0 because the rest of the graph is not bounded from below, and it also has two maximums because the graph of f of x is bounded from above. Here's to our next example. Find any local and absolute extrema of the function shown on its entire domain. F of x equals x to the fourth minus 2x squared plus 1. So simply graph the function and observe that the local max is 1 when x equals 0 while the min is 0 at x equals negative 1 and 1. The absolute minimum is 0 because it is bounded below while there is no absolute maximum because f of x increases without bound. So here's some more calculus terms to make your vocabulary boundless. Local extreme value theorem. If a function has a local maximum value or a local minimum value at an interior point c of its domain, then either f prime of c equals 0 or f prime of c does not exist. Critical point. A point in the domain of a function f at which f prime of c equals 0 or f prime of c does not exist. So what you should know is extreme values can occur at critical points and endpoints, okay? Let's face it, we'll never get anywhere without more examples. So we'll be going over A, B, and C of your 4.1 notes on page 2. So the objective of these problems is to find the absolute minimum and maximum values. So let's begin with A. F of x equals 3x squared minus 24x minus 1 on the interval negative 1 to 5. So at about the middle of your page, you should see a box of instructions for testing extrema. The first step is to find critical values. In order to find these values, we must first derive the function. After deriving it, we put it equal to 0 and solve for x. Our critical value here is 4. The second step is to plug these critical values back into the original function to find the points of extrema. We have our x values, but we are trying to find the minimum and maximum values at these points of extreme. So we need to solve for the y values. The third step is to repeat this process with the endpoints, which is negative 1 and 5 in this case. The fourth step is to analyze what you have found. The biggest number is the maximum, while the smallest number is the minimum. In this case, on the graph of f of x, you should see an absolute maximum at the point negative 1, 26, and an absolute minimum at 4, negative 49. Alrighty then, let's repeat this process with b. F of x equals 3x to the 2/3 power minus 2x plus 1 over the interval negative 1 to 8. You derive f of x to get f prime of x equals 2x to the negative 1/3 minus 2. Put that equal to 0, solve for x, and find that the critical values are 0 and 1. Now you plug in your critical points and your endpoints into the original equation to find the y values. You found the point 0, 1, 1, 2, negative 1, 6, and 8, negative 3. Clearly, the greatest number is 6, while the smallest number is negative 3. Therefore, making the maximum value to be 6 at x equals negative 1 and the absolute minimum to be negative 3 at x equals 8. Okay guys, you made it to C. Yay. F of x equals sine squared x plus cosine x over the interval 0 and 2 pi. Remember your trig functions? How about the derivative of your trig functions? Yeah? Cool, because you need that. So you derive f of x and get 2 sine x cosine x minus sine x, put that equal to 0, and solve to find the critical values to be pi, pi over 3, and 5 pi over 3. Yes, my partner's handwriting must have offended pi. I promise, that's a pi and not a random R. Okay, so practice makes perfect, right? So you guys must be near perfect now, right? Right? What's the next step? Did you say plug the critical values and endpoints into the original function? Wow, you're so good, man. Now, you find that there are two maximum values of 5 over 4 when x is pi over 3 and 5 pi over 3. And there is only one minimum, -1, when x equals pi. You are now a perfection of 4.1. So do this one on your own, okay? Here, I'll just start it for you. Did you solve it? This last problem is actually a special case. When you graph it, you can see that this is an inflection point, thus there are no extreme values.
The last question is taken from the 2003 AP Calculus AP exam multiple choice section. Alright, let f be the function with derivative given by f prime x equals sine times the quantity of x squared plus 1. How many relative extrema does f have on the interval 2 to 4? Since this question allows for a calculator, you would use your TI-84. First, plug in your f prime into y equals, and after that, you would change your window settings from x min to 2 and x max to 4. Press graph, and you would now locate where the graph changes signs, meaning when it changes from negative to positive or positive to negative. As seen on the graph, there are 4 different places where the sign changes. These are your relative extremas.